So we spoke a lot today about using agents, and I'm here today to tell you all about making agents, not just use them. So let's start by defining what an agent is. And we can start at defining what a chatbot is, which is basically an application built around a large language model, which takes an input, which is the context, and then gives you an output, which is content that's generated like text or media. In comparison with a chatbot, an agent also is built around the same concept. It's an application that wraps large language models, which takes context as an input. And instead of content, that's the output, it generates an actual action. It takes an action on behalf of us as the users. And it's able to do these actions because it has access to a set of tools that allow it to combine them together to make any sorts of actions like sending messages, etc. And as actions we take as humans, the actions that the agent can do can also range between complex and simple. So it can be as simple as sending a message or creating a file to as complex as booking a flight based on the calendar availability and the budget. And for these kind of complex situations, a single agent may not be as reliable to create the same result over and over again. And that's where a system of multi-agents comes in. It's basically a way to orchestrate the work of multiple agents to achieve the complex task, except that these small agents are laser focused on a smaller subset of tasks. And the reason why this is superior to using one single agent in achieving the complex task is it gives us access to the concept of modularity, which means that each agent has a smaller scope, and that means it's easier to maintain. We can then create teams around different agents and not just one team around one single agent. It allows us to do localized error handling, localized debuggability, test specific parts of the system, and experiment on only a specific part of the system much easier than if it was a single agent. Another benefit is it allows us to achieve deterministic flows and basically retrace the same kind of steps all the time, every time, reliably, instead of leaving it up to a single agent to decide based on the prompt if it's going to execute the steps in the right order or not. Another benefit of this is it allows us to combine models. So not all tasks require the most expensive and most capable large language model. Some of them can be easily done with cheaper models that are not reasoning. And this way, it can make the system itself cheaper, right? Because we can use cheaper models in some tasks. It can also make it faster because these cheaper models, which are not reasoning, they usually perform tasks at a much faster rate. And one more cherry on the top is it allows us to manage the context window. So each agent has a laser-focused context, which is only related to the task at hand, instead of having information related to much more else outside of that task. So this way, as my friend Gary also talked about, context engineering is very important to achieve reliable results. All right, so we have a system, or at least this idea that we want to build and why we want to build it. So how can we build it? Well, we can make it from scratch. We're software engineers, but there's already like frameworks on the market that do the heavy lifting for us because maintaining this kind of system requires a lot of infrastructure under the hood. And one framework I tried is from Google called Google ADK, which stands for Google Agent Development Kit. It's one of many on the market. Microsoft also has one. There are many actually popular such frameworks. But I got to try this one and play around with it. And it advertises itself as a flexible framework, as a framework that's actually model agnostic. So even though it comes from Google, it's not actually tied to the Gemini series of models. You can just hook in whatever model you want. It's also advertising itself as compatible with third-party frameworks. So even though you can use ADK as your main system development kit, you can also plug in other frameworks that are working in a different way in specific parts of the flow. Yeah, so in order to try this out, I thought I could make a test project and discover the features of the kit. And since we work in a development agency, I thought I'm going to make an AI agency, where I replace the roles of everybody else of us into an AI. And as we go through the flow, we're going to see different features that ADK actually supports and that I got to use. So it always starts with the user, right? Or a client, in our case, that wants to make an app. So they come into the office and they want to have a meeting. And since we're talking about a user, then we're also talking about a session. And so we need some kind of session management going on, and ADK actually gives us this out of the box. So this client has an app idea, and they want it to be implemented. And usually they sit down with a product owner whose job is basically to listen in, gather information, and write requirements that can be further passed down to the rest of the team. So this product owner is going to write these requirements, and they're going to pass them over to a designer agent, whose job is more focused on writing the design specs, right? So the handover of requirements is done through this concept of state, which is an object held inside the session, which is basically a data store where agents can store their outputs for other agents to read afterwards. It can also act as a store of other miscellaneous data that you as a developer can choose to inject at various points of the flow. So this designer is making design specs, then hands them over to a solution architect, which is responsible for making high-level technical specs that is passed around to both backend architect and the client architect. Maybe this is not exactly how it's done in all the studios, but this might be one way to do it, right? And already we see another concept, which is support for more workflow primitives like parallel execution. So it's not just about execution of sequential tasks, but also execution of tasks in parallel. And ADK supports this out of the box. It also supports looping tasks as well. So these two architects, they hand over platform-specific specs to developer agents. And when I say developer agents, what's the job of such an agent? It's basically converting these specs into code. So it's basically a coding agent. And we've been hearing so much about coding agents like Codex, like Gemini, like Cloud Code. So I thought, why should I actually write my own coding agent from scratch? I can just wrap Cloud Code under the hood. And that's what I did. And it was actually pretty simple to do. I just had to extend a base agent class from ADK and override two methods and just delegate the method calls to the Cloud Code SDK. So this is like another concept that ADK supports, which is high extensibility. It allows you to extend various parts of its flows. So back into the flow, these developers are building builds and are delivering them to the QA agent, which then can evaluate the builds and can decide to start a feedback loop with these developer agents until it decides that the quality threshold has been met, at which point it just finishes the flow and hands back the final build to the user, right? So in all this, we only focused as developers on the actual business logic of the system, on how to order all the moving parts together, and not really on the infrastructure underneath, like the how to make workflows, how to manage the state, and all that stuff. And those 4 features that you see there are only a small glimpse into all the features that the ADK supports. It also supports human in the loop, where the flow itself can be suspended until we receive feedback from a human, and then it can resume afterwards. It supports persistent memory across user sessions. It supports observability and also integration with various monitoring services. Also evaluation, which is basically unit or integration testing in terms of product development. It has support for MCP, and it has support for grounding, which is basically enhancing the context with Google search, or also search into the enterprise data. So you can see here these features again, just facilitate focusing only on the business logic and just leaving the rest to ADK to do the heavy lifting. So if you want to get started, I have a few tips. So the SDK comes both in Python and Java, and there is a choice to make. Python is the most common language for developing AI systems. So then you'll find more samples online, you'll find a larger community, but it's also a non-statically typed language. It's also maybe a language that you have to learn that's new, right? So there is a learning curve there. Although it's worth noting that it seems like it's the main SDK that ADK is supporting right now. It's the one they're heavily focused on. But the Java SDK is also there, and it's missing a few features, but they seem to intend on achieving parity at some point with the Python SDK. Then if you choose to go with Python, then I would really recommend going with Google Colab as a first step. It's basically an online platform that you can use from the browser, and it gives you access to a virtual environment where you can run Python code or run commands online. It allows you to install dependencies into this environment and save secrets. And it was, for me at least, a very good step into just trying out the different features of the framework and play around with it. And a final tip is, if you're planning to make an agent that where it needs to run code or maybe generate some files or download stuff from the internet, stuff that's risky, that you don't want to really run on your local machine, I would heavily recommend using a sandbox service. Sandbox is basically an isolated, secure container. It's like a micro virtual machine that runs in just a few hundred milliseconds instead of multiple seconds as in a virtual machine example. And there are services online like this that support this kind of services. E2B is one I've tried, and it's actually quite reliable. There is also one from Microsoft called the Micro Sandbox, which is open source, and it also allows you to run the infrastructure or run the framework on your own infrastructure instead of relying on a cloud service. So these are all the tips I have, but since I have more time, I decided not to include some other slides, but I can just mention briefly something else. So ADK supports basically deterministic flows. That's like the main focus of this framework. But that's not the only way to build a multi-agent system. There is also the way of indeterministic flows, where you don't really draw the flow beforehand. You can just delegate the task to the agents themselves to self-organize. And there are multiple ways of doing this that each framework adopts. Microsoft has one called AutoGen. There is another popular one called CrewAI, and another one called LangGraph. Each have their own pros and cons, but they're actually worth exploring because maybe indeterministic flows are more suitable to solving problems that are not yet completely well defined, where we don't really know exactly the steps we need to take. And so you kind of need use case by use case analysis and the creativity. And that's where it can shine. But otherwise, Google ADK has been a good experience so far to play around with, and I highly recommend trying it out. And yeah, that was my talk. Thank you.